So we talk about the mean, could be interpreted like the expected value. Now let's talk about finding expected value in a couple of examples. So in this example, it's a raffle with 3 prizes. The first prize is a $1,200 weekend package. The second prize is 2 tickets that are worth $250. And the third prize is a $100 gift card. So there are 1,000 tickets sold for $5. Find the expected value for purchasing 1 ticket. And the expected value in this case is, if you buy the ticket, what do you expect to get back from it? Of course, it doesn't work. It doesn't make a lot of sense for playing it one time only. But it would make more sense, for example, if this student organization made this same raffle every year, and I purchased a ticket every single year, after several years I played, I would have won maybe one time the prize and one of the prizes and lost to others. So in average, I would have, I'm going to get an average, what would be my outcome? Taking into account the times I won and I lost. This would only make sense if you do it several times, but that's many times. But that's the interpretation that we're giving it. That's the expected value. So the expected value for something like this is expected value from my point of view, from the person who bought the ticket, and it should be negative, right? I expect to lose money. I don't expect to win money. If you get a game where the expected value is positive, then the people who were making the raffle are not making money, they're losing. So in this sense, they would be, if you do it backwards, they're making money, I'm the one who's losing money, or whoever's buying 1 ticket. So there are a couple of things here to think about. One is that we should think of the output as a random variable x. So the x is, I'm going to buy a ticket, that's like playing a raffle, and the outcome is random. I could win the first prize, I could win the second prize, or I could lose my $5. Right? So if I don't win a prize, I lose $5, right? So it's a -5. So for the same reason, if I win, I'm going to subtract the $5 from my prize. Okay, like if I won the $1,200, I really didn't win it. I did win, but it cost me $5. So it's worth $1,200, but for me, it's like I would have got the package for a cost of $5. So I really had a net income of $11.95. Okay, so that's the way to interpret this. So the random variable looks like this. It looks like x, and so the random variable x and its discrete probability distribution looks like the values are x, -5. For the first prize, it's $1,200. For the second prize, instead of $250, it's $245 because I subtracted the $5. And let me write like this: for the third prize, instead of $100, it's $95. Okay, here is -$5 because I'm thinking that I subtract $5, right? And so I subtract $5 from each of the prizes. So now the probability here, there's only 1 ticket that wins the first prize, so I have the probability of 1 over 1,000. It's the same for the second and the third prize, right? There's not more chances of winning the second or third prize the way this is in. It's just they're going to pick the first number is the one who wins, and it's the order, but it's the same chance. So so it's 1,000 probability for each of the 3 prizes, but the probability of losing, you have 997 losing tickets out of 1,000, right? So it's a lot higher. So this is probably that you will lose the $5. So then, what is expected value? Well, we said it's the sum of the x times p of x. So you multiply these entries, this times that, and so on, and you add it up, and it's a -3.45. So you expect to lose $3.45. So this is how this works.